Now welcome back, and from our previous lecture we had this question that was example number 6, and we were supposed to look at it. Example number 6. Just a minute as I set up my so we had this question that is, we were supposed to the question is here. It says that we have this 1 over exponential x plus 2 equals to x minus 3 dy over dx, given that y is 1 and x is 0. So we are supposed to get the general solution, and again we'll get the particular solution at the given boundary conditions. So let's solve it. So we have 1 over exponential x plus 2 equals to x minus 3 dy over dx. So then we have given y equals to 1 when x equals to 0. So let's look at the solution, and the solution to this, we'll divide all through by 3, and dividing all through by 3, that gives dy over dx is equivalent to minus 1 over 3 exponential x minus 2 over 3 then plus x over 3, then multiply both sides by dx, and this now becomes dy equals to minus 3 of exponential, that is minus 1 over 3 of exponential x minus 2 over 3 plus x over 3 with respect to dx. Then from there we integrate both sides. So the integral of dy is equivalent to the integral of, so we can rearrange this to begin with x over 3 minus 2 minus 1 divided by 3 of exponential x with respect to dx. So let me just subdivide my book on my workspace. Now, from there, if you consider integrating both sides, we can simply say that we integrate each term independently. We integrate each term independently, and therefore this becomes y equals to, if we integrate the first part, this will give x square divided by 6 minus 2 of x divided by 3 minus this is minus into bracket minus a third of exponential x, close the bracket, plus constant c of integration. And this is simply what we refer to as our general solution. This becomes our general solution. Now at y equals to 1, when x equals to 0, that is our boundary conditions. So that one will give us our particular solution. So we can therefore say that y, so this is, sorry, y is equivalent to, first we simplify what we have here. We simplify what we have here. And after you've done your simplification, you will get that your constant c is equivalent to 4, and therefore y is equivalent to the particular solution now 1/6 into x square minus 4x plus 2 divided by exponential of x plus the constant of integration c, which is 4, close the bracket. So this is our particular, solution. That is our particular solution. So we can have another example, number 7, that reads 1 minus, that is into bracket 1 minus x, close the bracket, dy over dx is equivalent to 1 plus y square divided by y. So this one we are supposed to solve this. and see what the solution brings. So solution, so we first we can simply say first we divide both sides. So divide both sides by 1 minus x, and this one will give us dy over dx. It will give us dy over dx being equivalent to 1 plus y square divided by y, everything here divided by 1 into bracket 1 minus x. Then you multiply by the reciprocal. Multiply by the reciprocal of 1 plus y square divided by y. That is on both sides. On both sides. So this is simply the reciprocal of this is y. You divide by 1 plus y square this is dy over dx being equivalent now to 1 divided by 1 minus x. So from there we integrate both sides. Before we integrate, first we multiply both sides by dx. So multiply both sides by dx, and this one simply becomes multiply both sides by dx. So this one becomes y divided by 1 plus y square with respect to dy is equivalent to 1 divided by 1 minus x with respect to dx. So integrate both sides. Integrate both sides. So this is simply the integral of y divided by 1 plus y square with respect to dy being equivalent to the integral of 1 divided by 1 minus x with respect to dx. So this now simply becomes, if you look at this first part, here, we can simply say this is half integral of into bracket 2y divided by 1 plus y square, close the bracket, with respect to dy being equals to the integral of into bracket, this is -1, we transform it to be -1 over 1 minus x with respect to dx. So, and again, if you look at this, you can simply say integral of a quotient is simply the integral of a quotient is simply the ln, that is the natural log of denominator So therefore this gives half natural log, that is the first part, half natural log of 1 plus y squared plus y squared is equivalent to, again, if you look at the second part, it looks similar to the first part, but now this time around this becomes negative into the ln of 1 minus x plus constant c of integration. So we can simply say that, and put a star and say that constant c can be expressed in terms of the natural log of another constant. So that simply means we can say, for example, we can say that c is equivalent to the natural log of a variable a, or a constant a in this case, because we are expressing it in terms of another constant, and therefore it becomes half natural log of 1 plus y squared is equivalent to negative of natural log into 1 minus x, close the bracket, plus the ln of constant a, close this bracket again. So if we open the bracket on this side, this is half ln of 1 plus y square is equivalent to minus, can say this is equivalent to minus the natural log of a minus the natural log into bracket 1 minus x, and from there this side, if we apply laws of logarithms, and also on this other part we apply the power rule of logarithms, this becomes the natural log. Into 1 plus y squared, everything raised to half, is equivalent to the ln of a, that is natural log of constant a, divided by the natural log of into bracket 1 minus x, and if you look keenly, simplify this to become the natural log of 1 plus y squared raised to half, being equivalent to the ln into a, that is ln natural log of a, constant a, is divided by 1 minus x, and from there we can eliminate the ln on both sides. And this becomes 1 plus y squared, 1 plus y squared being equals to a, you divide by 1 minus x, and at this point we need to express as a square root. So express as a square root, and this simply becomes y squared is equals to a, you divide by 1 minus x, then you subtract 1, and this one you're subtracting here is the one that is here, so we subtract this one here, and therefore you can simply say that y is equals to the square root of a, you divide by 1 minus x, you subtract 1, or y is equivalent into, this is into bracket, a divided by 1 minus x, you subtract 1, everything raised to power half, and that is the end of our question. So we can have the two solutions, either y is equals to the square root of a divided by 1 minus x, you subtract 1, or y is equivalent to, what we have in here is simply the general solution, GE. This is our general solution about the general equation. So that is our general solution. So we can have another example. And this is example number 8. We have got x dy over dx being equivalent to tan y, and on solution of this, so this is got x dy over dx equals to tan y. So we divide both sides by cot x, and this becomes dy over dx equals to tan y. You divide by cot x. So we multiply both sides, we multiply both sides by dx, multiply both sides by dx. So this gives dy equals to tan y divided by cot x of dx. Then divide both sides, by tan y. So dy over tan y equals to dx over cot x, and this can be written as this can be written as 1 over tan y with respect to dy equals to 1 over cot x with respect to dx. So we integrate both sides. And the first part, this part here, it is simply saying the integral of 1 divided by tan y dy being equivalent to the integral of dy, that is cos y over sin y and the second part is equivalent, which is the integral of 1 over cot x with respect to dx. This is equivalent to the integral of sin x divided by cos x with respect to dx. So therefore, if we combine our two integrals, we can simply say that if we combine our two integrals, we combine what we have here, we combine these two, we can simply say that if we combine it, it has to give us this integral here. So therefore, this is the integral of cos y divided by sin y with respect to dy being equivalent to the integral of sin x, you divide by cos x d with respect to dx. So if we integrate this part, this is simply saying we get the integral is the natural log of sine y being equivalent to, if we integrate the second part, this is negative of the natural log of cos y, then you add your constant of integration, let's say constant k in this case. So from there we apply laws of logarithms. We apply the laws of logarithms. We apply the laws of logarithms, and this is simply saying or affirming that this is natural log of sine y being equals to the ln into cos of x, and this is not y, this is x, so change this to x, change that to x, cos of x, close the bracket, to the power of -1 plus constant k. And this simply implies that this is the same as, so the inverse of cos inverse, or the cos inverse what you have inside this bracket, is simply the natural log of sec x plus the natural log of maybe a constant a. So let me explain where our constant k goes. So from the previous example, we had said that this constant can be replaced, so we can replace this with the natural log of another variable, let's say in this case a, and that's why we are having it being replaced with the natural log of a. Therefore, if we apply laws of logarithms, we apply the laws of logarithms, and this is the summation law. Now this is therefore, and we eliminate the natural logarithms in each part, so this is simply sine y is equals to a sec of secant of x secant of x, and that now becomes our general, this is our general solution. That is our general solution. And maybe to tackle our last one, to look at our last example, I can say this is example number 9. We are told that find the particular solution, of differential equation. The differential equation is 5 dy over dx plus 2x equals to 3 given the boundary conditions, that is y equals to 1 2 over 5 is an improper fraction when x equals to 2. So give it a trial, take just a few minutes, you give it a trial, just a few minutes, give it a trial, and we'll look at the answer together to see if what you get is same to what I will have obtained. So take some few minutes, look at it, try it yourself. So let's see it, let's work it out. We have 5 dy over dx plus 2x equals to 3, and we have our boundary conditions at y equals to 1 2 over 5 and x equals to 2. So first you divide all through by 5, and this gives dy over dx equals to 2x. So you can simply say this is if we take the 2 to the other side, anyway, let's put it this way, equals to 3. So divide by 5 that side. So you can simply say dy over dx is equivalent to 3 minus 2x, you divide by 5. So from this, multiply both sides with dx, so this becomes dy is equivalent to 3 over 5 minus 2x over 5 with respect to dx. Then we integrate both sides. And this is dy, the integral of dy equivalent to the integral of, into bracket, 3 over 5 minus 2x divided by 5 dx. So the integral of dy, this gives y is equals to, if we integrate this, is 3x divided by 5 minus, integrate this other part, this is x square divided by 5. Then you include your constant of integration, constant c. Now up to this point we have gotten our general solution. That is our general solution. And to get a particular solution, that means you have to solve for constant c. And solving for constant c, we replace in this equation, we replace y equals to 1 2 over 5 when x equals to 2. So therefore this is 7 over 5. 7 over 5 is equivalent to 3 of 2 divided by 5 minus 2 squared you divide by 5 plus c. So therefore constant c is equivalent to so if we simplify this, we'll get c is equivalent to 1. So if we simplify, so if you simplify this summation, you'll get c is equals to 1. Therefore the particular solution will be y equals to 3 over 5 of x minus x square you divide by 5 plus constant 1. So that is the solution. That is the solution of that part or that question. And we can take another one. We can take another example. Can take another example, and this is number 10, example number 10, and it says obtain the particular solution of 2t into t minus d theta with respect to dt equals to 5, given that theta equals to 2 when t is equivalent to 1. So again, solution, we have 2t into t minus d theta divided by dt being equals to 5. So we divide all through by 2t, and this gives t minus d theta with respect to dt is equivalent to 5 divided by 2t, and from there we subtract t from both sides, or else we add t, we make d theta over dt the subject. So d theta over dt is equivalent to t minus 5/2t. So you multiply both sides with dt. Multiply both sides with dt. Multiply both sides with dt, and this becomes d theta equals to t minus 5/2t with respect to dt. So integrate both sides. So the integral of d theta equals to, this is equivalent to the integral of t minus 5/2t, close the bracket, with respect to dt. So the integral of d theta is theta. So theta is equivalent to, if you integrate this part, is simply half t squared minus 5/2 ln of t plus constant c. So again, this one is a general solution. That is a general solution. So for us to get our particular solution, we have to evaluate the function or the equation when theta equals to 2 and t equals to 1, and that means we get in, therefore, the value of constant c. We get the value of constant c, and this is simply, theta is 2, so this is 2, we replace theta with 2 here, equals to half, then we replace the t here with 1 into 1 squared minus 5/2 ln of 1, then plus constant c. So therefore constant c, if we make it the subject, this is equivalent to 2 minus half into 1 squared plus 5/2 ln of 1, and therefore constant c is equivalent to 3/2, equivalent to 3/2. That is the value of our constant, and therefore the particular solution will be theta is equivalent to, if you look at this, we can factor out half into t squared minus 5 ln of t plus 3, and this is our final solution. That is our final required solution, and from that one you can now work out any other given example at your own, because you've gotten all the required knowledge. And with that, I do believe that you are capable. Keep practicing more, keep more practice more until you become a pro, until you be perfect by practicing, as and with that, we've come to the end of the end of the tutorial or today's video. We'll meet next time in our next online session. So please subscribe, share, like, comment, and I'm much grateful for your audience. Thank you for watching, thank you for listening, and also thank you for being my viewer. I would request that you share. Tell a friend, let's watch the channel, share, let's grow together. My passion is that you understand and you pass in your exams. Understanding and passing in your exams, that is my core business, making sure that you understand, you pass in your exams. And some of the things that will make you pass in your exams: having this book. This one is very important. You can purchase the book. It gives you some formulas that are very necessary and that are very vital. Thank you.